A very warm good afternoon to every participant present here. Our beloved Principal, Reverend Dr. Praveen Martis, ST, the Director of Xavier Block, Dr. John De Silva, our distinguished speaker, Mr. Avinash, and my dear colleagues. I'm Shaila Rodriguez, and on behalf of the Department of Mathematics, I'll be the moderator for the duration of the workshop. As we're gathered here online for this 4-day workshop on Vedic mathematics, which is essentially a collection of ancient tricks to execute arithmetic operations faster and efficiently. To begin the workshop, let us first seek God's blessings to help us grasp and cherish the power of this ancient knowledge that we have the opportunity to study these 4 days of the workshop. Let us spend a moment of silence in prayer. Thank you. We're privileged to have with us the principal of our college, who's been a constant source of motivation and support and has made sure that learning takes place even in these challenging times. May I now request Father to deliver the keynote address.
Good afternoon to all of you. I'm extremely happy to be here this afternoon to inaugurate the workshop on Vedic mathematics by Mr. Avinash Daniel D'Souza. He is our own student, old student, and also the illustrious alumnus of St. Aloysius College. He also taught here for a while, and also he is well versed in mathematics. I'm extremely happy to have him here. Respected Dr. John De Silva, the director of Xavier Block. Respected Mrs. Priya Montero, the HOD of Mathematics Department. My dear members of the faculty and my dear students. It is a great thing to begin a workshop during this time of pandemic. We are all struggling and the second wave has hit us badly. But then at St. Aloysius College, we are always learning something, and our learning curve is always kept high. Because recently somebody called me up and said the amount of webinars the departments are organizing and engaging students at this time is very encouraging. And I'm very happy that the Department of Mathematics has organized such a wonderful workshop for 4 days on Vedic mathematics. And I'm sure all of you will definitely benefit from this wonderful workshop. And this is very important for us to continue. And you know, mathematics is one of the important departments. We may have physics, we may have chemistry. I come from the Department of Chemistry, but they all keep saying that without mathematics, we cannot continue. And even today, we are able to, after many, many years, able to see the atom, but then all that was initially visualized, initially started by the Department of Mathematics. Mathematicians of great scientific caliber started this science, and that science continues to motivate many of us and continues to guide us in different disciplines. That is very important, and all of us can learn from this very discipline of mathematics and also understand the past of mathematics. I think that is what I understand when they say Vedic mathematics, and definitely that will open our minds and hearts, and will be definitely able to think differently. I thank the Department of Mathematics, the director also, Father Dr. John De Silva comes from the Department of Mathematics, and all the members of the Department of Mathematics. I congratulate for envisaging such a wonderful 4-day workshop here at St. Aloysius College, and thank Mr. Avinash for being the resource person and guiding all our students and the faculty. Thank you. God bless us.
Thank you, Father, for your words of motivation. It is now time to introduce the resource person of this workshop, Mr. Avinash Daniel D'Souza. I call upon Ms. Melvita Barreto from our department to do the honors.
Good afternoon to all present here. I'm delighted to introduce the speaker for 4-day workshop, Mr. Avinash Daniel D'Souza. Mr. Avinash has obtained his Master's in Mathematics from St. Aloysius College, Autonomous, Mangaluru, and he secured the gold medal in MSc for the year 2016 to 2018. After MSc, he worked as a lecturer for a year in the same institution. He is the founder and Vedic mathematics instructor at Easy Math online classes. He is bubbled with many talents. Mr. Avinash anchors a television program in Daiji World channel and was a vocalist in Konkani musical piece titled Hasun Nasun. So with this introduction, without any delay, let me hand over the session to Mr. Avinash. Thank you.
Thank you, and a very good afternoon to all of you, those who are gathered in this Google Meet for the 4-day workshop in Vedic mathematics. It would be great if someone could put it in the chat box saying that there is no disturbance in the audio, as well as you can hear me properly and you can see me too. Okay, fine. Yeah. So before I begin the workshop of Vedic mathematics, I just want to give you 3 different instructions which need to be followed so that the entire process and all the 4 days of Vedic mathematics, we can have it in a good way. So first thing is, it would be great if we reduce using the mic. So the participants, we will try to avoid using the mic. In case if you have to ask any doubt, definitely you can on it. The second one is, it would be good if you can make use of the chat box in order to answer the questions, because I'll be keeping a track on the chat box, whatever answer you're going to put. So based on what answer you will give, I'm going to respond. Okay, so it would be great you keep you make sure that you will give the answers in the chat box, so that the workshop which we are going to conduct in the next 4 days, it will be an interactive. And the third one, it's a workshop, it's not a webinar. So kindly have a piece of paper or a book or something in order to write, so that whatever I say, if you feel something that is necessary, so you can definitely make a note of it. And also the different questions which I'm going to present to you in the workshop, you can definitely make a note of it and you can solve them. Okay, so with that, so I will begin. So give me a minute of time in order to display the PPT. I hope the PPT is visible to all of you, those who have even joined from the other link. Just give me a confirmation saying a yes. Okay, that's fine. Yeah. So to begin with, first of all, let's understand what exactly is Vedic mathematics. I'm sure you must have heard about Vedic mathematics even before the release of this poster of your workshop. You must have somewhere heard about Vedic mathematics. Okay, so Vedic mathematics is one of the ancient system of mathematics, which is actually based on the 16 sutras, which we call it as a formulae, and 13 sub-sutras, which we call it as the corollary, and these 13 sub-sutras are derived from 16 sutras. And the Vedic mathematics concept, it was a name given to the book which contains the collection of the lost formulae from the writings of Atharva Veda. And you must have heard the 4 different types of Vedas in your high school, that is Rig Veda, Yajur Veda, Sama Veda, as well as Atharva Veda. It's a large body of religious text originating in ancient India. One among them is Atharva Veda. The history of Vedic mathematics only says that Swami Jagadguru Shankaracharya Bharati Krishna Tirtha was the one who collected these lost formulae of Atharva Veda, but it's nowhere mentioned actually that he is the one who discovered. There are so many controversies are going on, research are going on based on who exactly discovered Vedic mathematics. There are negative statements too. But apart from all those things, the history only says for us that Swami Jagadguru Shankaracharya Bharati Krishna Tirtha, he has written a book, and that book is given the name Vedic mathematics, and that book contains all the collections of the lost formulae from the writings of Atharva Veda. And the entire branch Vedic mathematics, it is basically contains the 16 sutras, we call them as the formulae, and 13 sub-sutras. So any mathematical problem, it could be of any branch in the mathematics. So these problems can be solved by using one of these 16 sutras as well as 13 sub-sutras. If you are interested to look at the sutras, I'm just going to display the sutras, whereas here we are not focusing more on the sutras. We will focus on learning the method, how exactly we can apply the sutra. So among the 16 sutras, some of the popular sutras that we come across, we use in Vedic mathematics, it could be for the high school students, or it could be for the general category. That is the first one, Ekadikena Purvena, and every sutra has an English name. Every sutra has an English name, and for the first one, it is one more than the previous number. and even Nikilam Navatascharamam Dashata, and even this has an English name which we call it as all from 9 and last from 10. And you're going to learn this in maybe either in today's class or in the upcoming sessions. Then Urdhva and that is called as a vertically and crosswise in English, and it is one of the innovative techniques to multiply two-digit numbers as well as 3 digits and higher digit numbers. Then you have various other sutras. We can just have a look at it. And here we don't focus much on learning the sutras, but instead we will look at the method, and every method has an English name. So I'm mentioning every method with respect to their English name. And also there are 13 sub-sutras which we call them as the corollaries. So sub-sutras are something that are derived from sutras. You have theorem, and from that theorem you are obtaining different results, and that you call it as corollary. So the same thing happens even over here. So from the 16 sutras, there are sub-sutras which are derived. So these are the 13 sub-sutras I have listed. You can observe it in the screen. So with that, and this is the person, Shankaracharya Swami Bharati Krishna Tirtha, the great Indian monk who has collected all the lost formulae, and he lived in the year, he lived from 1884 to 1960. And this is the book I was talking about, which contains 16 sutras as well as 13 sub-sutras, and it contains a lot of methods involved based on these 16 sutras and sub-sutras. And even you can definitely browse for this book. It's you get its PDF also. The copies are also available, but you will require a lot of energy, lot of dedication to understand the book. Now, I'm sure you must be having one question in your mind, that is, why should I learn Vedic mathematics? I need to answer this before proceeding to the actual concept. Any mathematical problem, it could be of any branch, it could be arithmetic or algebra, it can be actually solved using mentally with these sutras. And Vedic mathematics is more coherent than modern mathematics. You need not even write, that's the main. So without writing, just by doing the method in the mind, you can actually reduce the time that you're taking, time that you're spending on one particular problem. So you can reduce the time and you can solve some of the problems in just 5 seconds. And also, if you use the techniques of Vedic mathematics, that will definitely increase your speed in calculation and also accuracy. So definitely, that means the chances that you will commit mistakes are reduced. So now, let's see who is going to identify this personality. You can put your answer in the chat box, and I'm sure you must have seen her or you must have heard about her. Let's see who is going to give the answer in the chat box. Okay, so Rahul Aroma is quick enough to answer. Okay, that's great. So let me move on to the next picture. So I think you can guess this movie. If you are not able to identify the previous picture, you can guess this movie. Yeah. So I can see the answer, and the movie is Shakuntala Devi, the Human Computer, and this movie was released last year in the month of July, and the movie is based on the life of Shakuntala Devi, the human computer, and Vidya Balan has put a lot of effort in projecting the life of Shakuntala Devi. And the first picture I have shown you, I think some of you have already guessed, that's great. So she is Shakuntala Devi, Indian mathematist. She's a writer and also a mental calculator. And she's popularly known as, she has got that title, the human computer. And she lived from 1929 to 2013, and those who have watched the movie of Shakuntala Devi, definitely I must be sure of her mathematical technique where she gives the answer for, it can be for cube roots, or it could be multiplication of 2 9-digit numbers. And she is very well known for the cube roots of 8 digits, and also the 7th root of the given number, and also for long multiplication. She has even multiplied 2 13-digit numbers, and she has given the answers within 5 to 10 seconds of time. And definitely, to imagine, to read out that number itself, if it's a 13-digit number, that will take a lot of time for us. And we should be proud because she's from our own country and she's from Bangalore. And she has got the talent what she had, it's from her birth. But we can definitely develop ourselves in order to gain such talents, because I'm going to show you one more picture now. You can guess this personality. He's very popular. and you can definitely guess that personality and you can say who is he. Let's see, I'll give you some time.
And already some of you must have, yeah, some of you have already given the right answer, and he is Mr. Neelakanta Bhanuprakash. Can anybody tell me what title he has got? Let's see, if you Google it, definitely you will get an answer for that. But anyhow, and he has got the title as World's Fastest Human Calculator. And this is not something that happened long back. It's not happened something many years back. It just happened recently, just 1 year back in the year 2020, that is last year. And he won a gold medal in the 2020 Mental Calculation World Championship at Mind Sports Olympiad, which was held in 2020. And can you guess his age? He's of your age. That is, he's just 21 years, and he's from Hyderabad. So it is not impossible for anybody to become a human calculator, provided you have to put some effort. So you can be the next human calculator, but you can see a star there, correct? No, you must have seen that star in most of the advertisement in your day-to-day life. What does that star indicates? That star indicates that conditions apply, and the conditions are you need to show your hard work, you have to give dedication, and with practice, definitely even you can give an attempt to become a next human calculator. Okay, so with that, so let me begin. So I'm going to introduce the first technique of Vedic mathematics, that is squaring of numbers ending with 5. Okay, so how exactly and how easily we can find the square of a number which is ending with 5. So basically, the numbers which are ending with 5, in the sense, the numbers which have 5 as their units digit, and you all are already familiar with that. It could be 15, 25, or 105, or 1005. And all these numbers, the numbers which are having 5 as its units digit, these are the numbers which are ending with 5. And if I ask you what does squaring mean, I believe all are degree students, so you all are familiar with the concept of squaring. So squaring means you're just multiplying a number by itself. As an example, for 2 square, you just multiply 2 into 2, which gives you 4. In the same way, for up to 5 square, for 5 square, it is 5 into 5, which is 25. In case if I ask you for 10, it is 10 into 10, which gives you 100. So suppose you have to find the square of 65. How exactly you can do? The normal method, what you follow is you do it in this way. If you have to find the square of 65, you will multiply 65, you will write it like this, 65 into 65. Then you will start multiplying by 5 first. And once you finish multiplying 5 by 5, 5 by 6, then you'll start multiplying by 5, start multiplying by 6 to 5, then 6 to 6, and then you will add up and get the answer. But instead of that, there is a unique technique which will give you the answer in just 5 seconds. Okay, so try to understand first, then you can try it by yourself. So in Vedic mathematics, basically we write for multiplication the numbers one below the other as 65 by 65. So, and the methods are discussed in such a way that we will obtain the left part of the answer and then we will obtain the right part of the answer. So this is one of the ways in which you can find out the product, or it could be a sum of any question. So one is we are finding the left hand part of the answer, and then we are finding the right hand part of the answer. So here what you can do is, in order to obtain the left part of the answer, you look for the digit apart from the units digit. We are discussing with the squaring of numbers ending with 5. You consider the digit apart from 5, apart from units digit, which you have is 6. Okay, you're multiplying the same number, so it's 6 itself in both the case. So what you can do is, what comes after 6? So after 6, the next number is 7. So you have to multiply 6 with 7. And if you multiply 6 into 7, that gives you 42. And to obtain the right part, what you can do is you can simply multiply the units digits together. You can multiply 5 with 5, that gives you 25. So it's easy to find out. You need not even follow that 3 steps multiplication where you have to multiply by the numbers, then you have to add. Instead of that, just by following this method to obtain the left part and right part, and then you can get the final answer as 4225. I'll repeat the method once. So you consider the digit apart from units digit there, which is 6. To obtain the left part, you multiply 6 by its next number. So after 6, it is 7. 6 into 7, that gives you 42. And to obtain the right part, you have to multiply the ones digits. I think you call it as a units digit. It's one and the same. You have to multiply the units digits together. So left part is 42 and right part is 25. Combine them, that gives you the final answer, which is 4225. So now I'm going to display a question for you all. So you can just look at the question and give the answer in the chat box. So find the square of 85. Let's see who is quick enough to give the answer. Okay, so Purnima and Raul as well as Tommy and Rion are quick enough to give the answer. That's great. To obtain the left part, you have number 8 there. And what comes after 8? It is 9. So you just multiply 8 with 9, which gives you 72. And to obtain the right part of the answer, you have to multiply the units digits together. So 5 into 5, that gives you 25. And I want you to try this. So try these 5 problems. Some are little tricky there, where you have to find the product separately. And once you get the answer for all the 5, put the answer for all the 5 in the chat box. I'll give you a minute of time. Try by yourself. This is how you need to learn. You can even just look at the screen and you can just go on typing the answer in the chat box, because it's easy. You have to find the left hand part of the answer and then the right hand part, combine them and write the answer together. Okay, so Purnima is quick enough to give the answer. That's great. Then Raul, Joswin. Okay, wonderful. I'll give a few more seconds for those who are still trying. Okay, so I think we will discuss. For 15 square, you see what comes after 1, which is 2. So 1 into 2, that gives you 2. And 5 into 5, that gives you 25. So you get 225, and moreover 15 square, the answer you already knew it. So for 25 square, what comes after 2, which is 3. So 2 into 3, that gives you 6. And multiply 5 into 5, that gives you 25. So 625 is the answer. For 105 also, you can follow the same technique. You consider the number apart from the units digit. You have 10 there. And what comes after 10, which is 11. So, and multiplying any number by 10 is easy. So 10 into 11, that gives you 110. And multiply 5 into 5, that gives you 25. So your answer is 11025. And for the fourth one, for 75, I'll just display the answer. 7 into 8, that gives you 56. And 5 into 5, that gives you 25. And even for the last one, so here you will have to work little bit. That's it. You have to multiply 11 by 12 there. So 11 into 12, which gives you 132. And you have to multiply that 5 by 5, which is simple, which you already know it. So that gives you 13225. So it's not only for smaller number, even when it comes to the larger number also, the method will be easy. Suppose you want to find the square of 1005. If you had followed normal method, I'm sure you would multiply by 5, you would multiply by 0, then once again by 0, then by 1, and then add it and write. The same technique can be followed whenever you have the numbers which are very simple. So for 1005, so what you can do is you consider the number apart from units digit. The same method follows. You have 100 there. Just multiply 100 with its next number, which is 101. So 100 into 101, that gives you 10100, and multiply 5 by 5, that gives you 25. So you get the final answer as 1010025. And in Vedic mathematics, we tell the number digit by digit. We call them as digit by digit, than reading it as a number, how you make use of the Indian number system and read it. So we will read it digit by digit, so that it is easy for us to read, and our time also will be saved in order to get the answer. In the same way, for 10,005 square, if you have to find 10,005 square, you can definitely find it in the same way. So you have number apart from 5. I want to see the answer from you for this, because some will go in multiplication of the left hand part there. Okay, so that's great. I can get the answer. So you have 1000 and its next number is 1001. Multiply both, you get 1001,000, and then 5 into 5, which gives you 25. So the final answer that you get is 100,1,000,025. Okay, So now, whether this method works only if you have the units digit to be 5. No, it is not necessary. The squaring of numbers ending with 5 means ending with 5 doesn't mean that it is only the units digit. Even it can be a decimal number where in the decimal number you have the last digit to be 5. Even in that case also, the same method works. Only you have to be careful in inserting that decimal point while you get the answer. As an example, if you have to find what is square of 7.5, you just ignore that decimal first. How exactly you normally multiply the two decimal number? You have learned this in your school. You just ignore that decimal and then you will calculate where exactly you have to put the decimal after getting the answer. The same thing follows here. You ignore the decimal and you take that number to be 75 multiplied by 75 and follow the same method. After 7 you have 8, so multiply by that, so you will get 7 into 8, which is 56, and 5 into 5, that gives you 25. Now the question is where to put the decimal. Okay, I hope you remember when you are multiplying two decimal numbers, you will count how many digits are there after the in the first decimal number, in the first number, how many digits are there after the decimal point. The same thing you will count for the second number also, how many digits are present after the decimal point. You will combine both, you will add both the number of digits and then you will put the decimal. The same thing
We should
follows
put
here.
after two numbers.
Yeah, the same thing follows here. You have after the decimal you have one digit, so you're multiplying 7.5 by 7.5. So in the answer the decimal point will be after the decimal there should be two digits. So already some have given the answer for the next one. So if you have to find 11.05 multiplied by 11.05, the same thing follows here. So you can consider it as 1105 multiplied by 1105, and you can definitely check. The same method follows because it's numbers ending with 5. So after 101, 100, you have 100, 110, you have 111 there. Multiply both, you get 12210, and multiply the units digits together, you get 5 and 5. And don't go to put the decimal point where the left hand part and right hand part get separated, but count. You can just remember this whenever you're finding the square of the number. You have two digits after the decimal, double it, so that means in your answer there should be 4 digits after the decimal point. Okay, so in case, I think it would be great if you try some of the problem, especially the
We have to
question
count from right hand
E,
side to put decimal point.
E. So you can try question B, D as well as E. So there you have to work little bit. And if you could try all of them, that would be great. Okay, I'll give 1 minute of time because it will not take a lot of time to get the answer for that. I expect everyone to try. It would be great. I can see some of them giving the answers. You can give a try with all the numbers there. I'll give you a few more seconds for all those who are still solving. Those who are finished can try the other two questions as well. Okay, so I think we will begin from the first one. I'm expecting somebody to give the answer for the last question there, for question number E. Okay, so to find 12.5, actually you need not even write it like this. So 125 multiplied by 125, this method actually you can avoid. Just by looking at the number itself, you can get the answer. So you have 12 there, and see what comes after 12, which is 13. You can multiply 12 by 13. If you multiply 12 by 13, you get 156. So I'll just write here 156, and 5 into 5, that gives you 25. And you have after the decimal there is one digit, so in your answer there should be two digits after the decimal. The same thing for next one, where you have to multiply 10.05 by 10.05, the previous question which are displayed on the slide, the similar method. So you consider it to be 100 there, you consider it to be 100, the number apart from units digit. So what comes after 100? It is 101. So you can just write 101 and multiply by 100. So there will be two zeros, and then you will have to write 25 because 5 into 5. And where should be the decimal? You have two digits after the decimal. So in your answer, there should be 4 digits after the decimal. So 101.0025 is the answer. The same thing follows for question C, where you have to find 0.95 square. So you consider the digit apart from units digit, which is 9. So after 9, you have 10. So multiply 9 with 10, which gives you 90. And 5 into 5, that gives you 25. And here, if you observe, there are 2 digits. In your answer, there should be 4 digits after the decimal. So a decimal point will come over here. And at the same time, insert a 0 at the beginning. So even you can try the next one, 19.5. You multiply 19 with 20, which gives you 380, and 5 into 5, that gives you 25. So in your in the question, there is 1 digit after the decimal. So in your answer, there should be 2 digits after the decimal, exactly double. So our answer is 380.25. Now, for the last one, this was a little bit tricky there, where you had to multiply 0.015 by 0.015 or 0.015 square. So what you can do is you just consider the number apart from units digit. You have 001. You can just consider it to be 1. And 1 multiplied with the next number 2 gives you just 2. And you have 5. Find its square. That gives you 25. And where should be the decimal now? In the question, there are 3 digits after the decimal. In your answer, there should be 6 digits. So you have to insert the appropriate number of zeros so that you get 6 digits after the decimal. So your answer is 0.000225. Yeah. And remember, in Vedic mathematics, the method that we have 2 different kinds of method. One we call it as the general method, and the second one we call it as the specific method. The general method can be used for any of the numbers. General method can be used for any of the numbers. There is no restriction anywhere. Whereas for specific methods, these are the tricks. So when it comes to the tricks, definitely you cannot follow the same trick for everything. Correct? No, the same trick cannot be followed for everything. So the trick will work only for one particular case. So it will not work for all the cases. But anyhow, however, there are some technique which will work for 2 different cases, or we can use for 3 different cases also. And this is one such technique where you have squaring of numbers which are ending with 5. And here we use the sutra, that is ekadikena purvena, that is one more than the previous number. That is what we followed there when we are obtaining the left part of the answer. So using the same technique, there is an extension principle to this. That extension principle says the same method, the same rule can be applicable not only for the numbers which are ending with 5, but also to the numbers where you have the last digits or the units digit which add up to 10, and the remaining digits are same. So the second way where you can use this technique, that is, you have to make sure when you have to multiply, okay, when you have to multiply, whether the last digits, the units digit will give you the sum to be 10, and the remaining digits are same. And even then you can use the same technique. So one such example is over here, where you have to multiply 66 by 64. So first you have to check before applying the method whether the units digit add up to 10. You see the units digit, you have 6 and 4. On adding 6 and 4 gives you 10. And the second condition says the remaining digit should be same. If the remaining digit is a single digit, it has to be same. If it is a 2 digit, it has to be same in both the numbers. So then you can obtain the left part of the answer by considering the digit apart from units digit, which is 6 here, and 6 into its next number, 6 into 7, that gives you 42. And then you can multiply the units digits together. If you remember, while finding the square of ending with 5, I was stressing on multiplying 5 by 5 than saying just find the square of 5, because this is the reason. Actually, it's one and the same anyhow, but since there is an extension, that's the reason I was stressing on multiplying 5 by 5. So here you can multiply 6 with 4, which gives you 24. So the answer that you get is 4224. So can you try the next one, where you have to multiply 107 by 103? First check whether the units digit add up to 10 and the remaining digits are same. That is more important. Okay, so Purnima Natsit is quick enough to give the answers. That's great. So units digit 7 and 3, which add up to 10, and you have the remaining number to be 10. It is 1 and 0, both the digits are same. Then you can apply the same technique. So 10 into its next number, 10 into 11, which gives you 110. And multiply the unit digits together to obtain the right hand part of the answer. So 7 into 3, that gives you 21 there. So combine both, you have obtained the left part and right part. Your final answer is 11021. Okay, so I want you to try this one now. 91 multiplied by 99. I want few more students to give the answer. Okay, so many are giving the
909.
If it is a right answer, I'll definitely call out your name. Okay. Okay. So Neola, Akshata, then Mohit. So they have given the right answer. It is not 909 here. It is not 909. Let me tell you why. So units digit add up to 10. You know that, and the remaining digits are same, which is 9. So after 9, it is 10. So 9 into 10, that gives you 90. And to obtain, you have to remember one thing. In this method, okay, only in this method, whenever you obtain the right part of the answer, the right part of the answer should always contain a two-digit number. It should always contain a two-digit number. Suppose if it is a single digit number, then you have to convert that single digit number into a two-digit number by adding a zero. So if you multiply 1 and 9, you get 9, but you have to convert into a two-digit number, so it becomes 09. So the answer is 9009. It is not just 909. That is the reason why the answer is 9009. Even if you multiply using your conventional method of multiplying 91 by 99, you will get the same answer. Okay, now you can try this because this is pretty easier, where you have to multiply 51 by 59. The same method follows. If there is a single digit, convert it into a two-digit number. Okay, so many are quick enough to answer. That's great.
3009.
So 5 into its next number. So 5 into 6, that gives you 30 there. And 1 into 9, that gives you 9. But as I said, whenever you get a two-digit number, you have to convert into, whenever you get a single digit number, you need to convert it into a two-digit number by adding a 0 while obtaining the right part of the answer in the extension technique of squaring of numbers ending with 5. So since these are specific methods, the specific conditions are followed only to the specific method. Okay, the same thing you cannot say somewhere else, you have to write it as a two-digit number. So since it's specific, it only applies only in this case. So this is one of the basics of Vedic mathematics, a 10-point circle. I've just included it over here for those who are finding little difficult in addition. Since they are degree students, I know all are very thorough with addition, but if you do not know, if you had not learned this particular 10-point circle, definitely you can give a try on it, because it will even increase your speed much faster. You may feel that the concept is very silly, but I would like to share it with you all, because of this, definitely at least you can increase your speed in calculation little bit at least. So the 10-point circle says, as the name says, you have a circle, and on that circle there are altogether 10 points, and these points are numbered from 1, 2, 3, 4, 5, 6, 7, 8, 9, as well as 10. And you can see the numbers. There are so many numbers which are facing opposite to each other in the circle. So you can see 1 and 9 are facing opposite to each other. On adding 1 and 9, you get the answer as 10. In the same way, 2 and 8, on adding both, you get 10. So in this 10-point circle, the opposite numbers, whichever are present, on adding them, you get the total to be 10. At the same time, you consider any one number on this. You consider, as an example, it's 9. You subtract that number from 10, you get the opposite number to be the answer. We call this as the complement of each other. You call the complement of 9 to be 1. In the same way, you call the complement of 1 to be 9. And we will be using the term complement in upcoming sessions, and that's the reason I've introduced it over here. So the complement of 9, that means you are adding one particular number to get 10. In the same way, if I say complement of 6, it is 4, and the complement of 4, it is 6. And for 5, you have to add 5 to itself, so complement of 5 will be 5 itself. So if you just remember these pairs, 1 and 9, 2 and 8, 3 and 7, 3 and 4, and 5 and 5, you can definitely increase your speed in calculation, where you have to add big numbers. You can just identify those numbers which are ending with these pairs. You can combine the numbers which is ending with 9 and which is ending with 1, and you can add it together. I know you have calculators, but remember you cannot use the calculators when you're attending some competitive exam. Okay, so the modern gadgets are making us lazier day by day, but of course there are so many benefits too. But at the same time, we have to make ourselves in order to get creativity in our brain. Okay, so I think you can try these 4 questions in the same way, and you can just make use of 10-point circle just to check. You can just have a look at the units digit and see that whether they add up to 10 or not. And once you finish the 4 questions, you can get the answer in the chat box. So for the first one, where you have to multiply 84 by 86. So what comes after 8? You know it, it's 9. So you get 8 times are 72 and 4 6 are 24. In the same way for the second one, where you have to multiply 23 by 27, the same method follows. 2 3s are 6 and 3 7s are 21. And for the third one, remember in the third question, you get a single digit number while obtaining the right part of the answer. So convert it into a 2-digit number. So you get 11009. And for the last one, 58 into 52, you get 3016 as the answer. Okay, so this is not required. You can actually try it using the same method. So now, once again, you can even try this for where you have the decimal number. It's simple. You can just, same as the previous one, how I explained you for squaring of numbers ending with 5, you just ignore the decimal and write the number where you have 74 multiplied by 76, and you know it, how to obtain the left part. You get it as 56 and right part as 24, and you can put the decimal based on how many digits, after the decimal how many digits are present. In the first one it is 1, second one it is 1, so 1 plus 1 2. So after the decimal in the answer there should be 2 digits. You can even try this a little different way. The question is a little bit different than the previous one. So where you have to multiply 1.17 by 1.13. So you have 100, you can write it as 117 multiplied by 113. And you know how to obtain the left part and the right part. So left part 11 into 12, which gives you 132, and right part is 7 into 3, which is 21. And then you can put the decimal point based on how many digits are present after the decimal point in the question. So that is 2 plus 2, so 4. So the answer is 1.3221. Okay. In this, I don't want you to try all of them. I just want you to try question number E and question number C in the same way. Okay, and also D. 3 questions you just give a try, because there are 3 different types there. It's not the exactly same. Try these 3 questions and you can give your answers in the chat box. Try question C, D as well as E. Okay, some are already quick enough to give the answers. That's great. Okay, I think we will discuss question C. So it is 1.008 multiplied by 1.002. It's same as 1008 into 1002. So you have 100 there. So what comes after 100? That is 101. So 100 into 101 gives you 10100, and multiply 8 into 2, that gives you 16. So you have 3 digits after the decimal, and even here 3 digits after the decimal. So 3 plus 3, 6. So in your final answer, there should be 6 digits after the decimal. So your answer will be 1.010016. You can even try the next one where you have to multiply 50.9 by 50.1. You can just consider it to be 509 by 501. So after 50, you have 51. 50 into 51, what do you get? You get 2550, and 9 into 1, it is 9. But as I said, you're supposed to convert it into a 2-digit number and write it as 09. And after the decimal, there is 1 digit and there is 1 digit. So altogether, there should be 2 digits after the decimal. And the next one, where you have to multiply 0.04 by 0.06. I'm sure if you had followed the old method, you would have start multiplied by 6 first, and then you would write 2 steps of zeros and then add. But instead, you know the technique. You can just consider it as 4 into 6, you can just multiply in that way also. Even that will also work. 4 6 are, you get 24. And whereas the other part, it will just remain to be 0, because according to our method, obtaining the left part, after 0, you have to multiply with next number, 0 into 1. 0 into 1 gives you 0 itself, which is a waste of time doing it. So you get 24 there, but only thing is where to put the decimal. So after the decimal point, you have 2 digits, and here you have 2 digits. So in your answers, there should be 4 digits after the decimal. So I'll insert 2 zeros and also one more 0 in the beginning. So your answer is 0.0024. Okay, so there's one topic, it's a small topic, so I'm going to finish this. So if you have to square of numbers which are ending which are in between 50 and 59. So as I said, this is also a specific technique, and it is pretty easy to find, because you're discussing, just remember it as you're discussing with the numbers which are in between 50 to 59. Okay, as an example, I've considered 57. So first thing, you have to find the square of 5. And what is 5 square? That's 25. You add that 25 to units digit. And what do you get if you add 25 to 7? You get 32, and you can write it 32. This will be the left part of the answer. And to obtain the right part, you have to find the square of one's digit, which is 7 into 7. That gives you 49. So this method can be applied whenever you have to find the squares of numbers which are in between 50 to 59. So you just have to add. You can actually simplify this method, and you can just remember it as add 25 to units digit to obtain the left part. So 25 plus 7, that gives us 32. And to obtain the right part, you just have to find the square of units digit. I hope it's clear to you, and I want you to try the next one here. Find the square of 52 in the same way. Just see how to obtain the left part of the answer and how to obtain the right part of the answer. Okay, so I can see varieties of answer there. So let's see who has given the right answer. So suppose you want to find 52 into 52. The method same method follows. You add 25 to units digit. Units digit is 2. So 25 plus 2, that gives you 27. So write 27 as the left part of the answer, and to right part of the answer. Because of that right part, I can see the two different varieties in the answer. So to obtain the right part, you have to multiply 2 into 2, and 2 2s are, that gives you 4. But as you remember, even here also the same method follows. The right hand part of the answer should always contain a 2-digit number. So instead of writing just 4, you write it as 04. So you have already obtained the left part as 27 and 04 as the right part. So your final answer is 2704. And this is the method. In case if you want, you can just take a screenshot of it, how exactly it works. And you can even try these two questions where you have to find the square of 53 and 58. You can follow the same method, obtaining left part and then the right part, combine them and write it together. Okay, so Joswin Natchit is giving the answers. Good. I can see so many of them giving the answers on the other link also. Okay, that's wonderful. So for 53, you add 25 to 3, 25 plus 3, that gives you 28. And to obtain the right part of the answer, multiply 3 and 3, that gives you 9. But as I said, it has to be a 2-digit number. So instead of 9, you write it as 09. And also for 58, the same method follows. So you add 25 to 8, which gives you 33, and multiply 8 into 8 to get the right part of the answer, which gives you 64 there. So using the same technique, you can give a try for all the numbers from 50 to 59, and the same technique works. You can actually get the answer within 2 to 3 seconds of time. Yeah. With that, I'm going to stop today's session. So I think your mom wants to talk something. I think she can talk.
Yeah, thank you, sir, for this wonderful session. You definitely got our minds racing with numbers. Before we end the session, I request all the participants to fill this feedback form that I'm sending you in the chat right now. I hope you all had a fruitful session. I request you all to fill the feedback form, and we'll see you tomorrow at 3:30 sharp.